Innovation Café. It's nice that you've all come in between showers, as today was quite wisselvallig. For those of you who haven't been here before, we are a weekly networking event where we offer presentations on the subjects of technology and or design. Today we welcome Cristina Nan, who will tell us more about using natural materials for 3D printing and other forms of digital craft, which we're very excited about. We have a private event in the restaurant, so the drinks afterwards will just be in this space, but we also always offer the opportunity for people to have a meal for €19.50, and we have organized another meeting space for that, but I will tell you more about that later. But first, enjoy the presentation.
So, thank you everyone. Thank you very much, Anouk, for inviting me and having me here. My name is Cristina Nan, and just as a quick introduction about myself, so I'm currently an assistant professor at the TU Eindhoven. I studied architecture, and I worked as an architect also for 3 years, but I have a PhD in additive manufacturing and robotics for architectural purposes. First, to start off the lecture, right? So looking at the context of construction and architecture overall, right? So this is typical, right, a representation at least of typical vernacular European architecture, right? Timber-based, where the mode of construction that was employed was very much based and anchored around craft and craftsmanship and craftsmen. Working at it, right? If we make a bit larger jumps through architectural history, right? Here we can see, for instance, in the Middle Ages, the building of a cathedral and how the construction sites are arranged. You will see there in between, right, scaffolding, you will see there machines and a variety of tools, but again, labor is organized around the human and human production. If we make a few more jumps through history, we end up at the Industrial Revolution, which brought to us the factory and the machines. Was a revolution, we don't need to get into detail, everyone is aware of it, in terms of energy, in terms of production. And here you can see a drawing of the on-site assembly of the Crystal Palace. What industrialization made possible was mass production. Right, so the mass production via the machines, which then allowed for this type of architecture to physically manifest itself. Here we can see the Crystal Palace in London. The actual building does not exist anymore. Again, made possible through prefabrication and factories. If we look at today's construction sites, right, they're a combination to some extent of the medieval age and the Crystal Palace, a lot of prefabrication happening, but the biggest change that happened, or paradigm change that happened in the last decades in terms of architecture and construction is the robotic industrial arm. Robotic industrial arms, you can see them, right? We also call them KUKAs. It's the orange guy. They are the orange guys that you see there in the image. KUKA is the brand name or the company that produces them from the car factory. And there you have the automized robotic assembly line. Now, what architects did in the last decades was to take the industrial robot arm and implement them within architectural practice. What is the difference to the machines of the industrialization with regards to the industrial robot arm? It's mass customization. It doesn't matter for the robot if it produces, for instance, if it cuts out 100 times, 1,000 times the same piece, or if it cuts out 1,000 times self-similar yet non-identical pieces. Yeah, so here we can see the industrial robot arm. We call them, or they are called non-specific tools of fabrication. Why non-specific? Because they can execute a variety of different actions. You can see here, let's call it the naked industrial arm, right? So at the very end, the tool is missing. The tool called an end effector can be literally anything. It can be a spray can for applying paint. It can be a pencil for drawing. It can be a saw. It can be a milling device. It can be a welding device. And the use of the industrial robot arm in architecture has led also to the democratization of the fabrication processes. So here you can see, right, a wide array of new tools that are suddenly available to architects and designers everywhere via open source platforms. So for hardware and software, here we can see, right, microcontrollers from desktop fabrication tools. It has become increasingly cheap and handy to just buy your own 3D printer, to build your own 3D printer, be it with PLA, be it with clay. And then we have also software such as Rhino or with the plugin Grasshopper, which are being used for computational design. And what this availability of different tools is leading to, it's a rethinking and a redesign of the process. And which process? Not only the process of design, but more importantly, the process of making, the process of fabrication. By being able to hack machines, to modify machines, you can change the entire production line and you can rethink that process. A particular material choice, right? So we can use a robot to work with wood, to work with clay, to extrude concrete. But that will have a particular implication on the way the machining is used. It will have a particular implication for the way the structure works, the assembly works, the design, right? Not any type of form wants to be built out of any type of material, right? If we're looking at walls, maybe there's particular set of materials you should be rather inclined to looking at than others. So the moment you tweak one of these parameters of fabrication, nearly everything has to be tweaked in accordance. And now to give you some examples of what the rethinking and redesign of process means. So you saw in the slides before the industrial robot arms, they're big guys, right, can weigh up to 2 tons and more. They require tracks. The moment you want to bring them outside of the factory, you will have a logistical issue on your construction site. And this was a project that was called Mini Builders at the EHV Institute in Barcelona, where I did parts of my PhD, a part of a research group, where we were thinking, why can't a robot for construction, for 3D printing, be the size of a normal hand tool to avoid the complications that a regular 2-ton robot would bring with itself. So here you can see also the effect of open source software, right? All of us working on these projects were architects by training. We didn't really have any type of training in terms of machine engineering, yet we were able to build our own robots, to program our own robots, and to design also the process of the fabrication. Here you can see them on site printing a larger structure with an external extrusion system connected to it. Another example of how one can redesign and rethink process, this is from the University of Edinburgh, where prior to joining TU Eindhoven, I was professor for 5 years. Our student Charlie, he decided to build his own 3D printers, one for silicon and one for clay. We found this very interesting, and we thought, what is happening when you use the silicon printer to also print on textile? There you can see the spend in textile. Why was textile interesting for us? So if you think, for instance, of concrete, there are several ways of working and building with concrete. Now you're casting concrete into some sort of wooden or steel-based formwork. We used textiles as the formwork, and normally if you think also of concrete, right, the way the surface looks, it's very much flat, right? It doesn't want to be ornamental because of the production process. Well, we use the silicon as part of the formwork. So there you can see, right, the formwork, we are casting in the concrete and then taking off like a corset the textile formwork, and you start to have this imprints on the concrete which you normally wouldn't have with regular casting. Right. There you can see the first column. There you can see the reusable formwork with the silicon still on it. And then we tried to push it a tiny bit further. So what we then became very confident was to be like, okay, what if we want to achieve more intricate, more complex patterns? So we explored that too. And this was then this type of column that came out of it. Again, through regular processes of fabrication with concrete, you wouldn't be able to achieve in one go this type of surface texture and resolution. Another way of rethinking process of this is, for instance, from the Institute of Computational Design at the University of Stuttgart, where they rethought the process of weaving within a robotic context. So there you have two KUKA robots that collaborate with one another, and via a rotation in different, simultaneous rotation in different directions, they weave glass fiber and carbon fiber together. It's becoming really stiff because they also apply then subsequently epoxy resin on it. And there you can see, right, the result of it, a pavilion made out of this type of woven structures, which you normally wouldn't think of, right, in the context of architecture. So what is really, really important, it's all about, in my work, research and teaching, it's about process. It's not so much about saying from the very start, oh, this needs to be an outcome, right, or we envision this type of column, this type of structure, but rather saying, oh, what is happening when we change the parameter of the process, when we intervene, and what is happening is left as an open question. Right, and now to give you some other examples of rethinking the process. And for me, it's really interesting what is happening when low-tech, particularly in terms of materials, is meeting high-tech, right, in terms of the fabrication. This is a project done by my students at the University of Edinburgh, where as an assignment, they got our staircase in the building, right, total height of over 10 meters, and they were tasked to design a hanging structure within that staircase just made out of paper. This was their design proposal for that staircase, and then you have to start to rationalize the design and to think, okay, how do I actually fabricate and make it? Paper per se is not a stiff material. It only becomes stiff the moment you add folding. So what they did, they subdivided the whole structure into triangles. And as you can see here, right, we have some folding lines, and then the folding lines are just stapled next to one another. Of course, you'll end up, so we had, I believe, over 1,000 triangles. Yeah, they're self-similar yet not identical, so you need to know where their position is. This is why we applied a numbering system. The moment you scale it up, you have these big guys all cut out by hand. It is doable within one day by 20 students. And then you have a bit of a more complex system. Also, anecdotal, funny side fact, they wanted to laser cut it first because manual labor, it was just inconceivable that we should cut 1,000 pieces, will never come to an end, right? Then, this is also here why the name blackout. We had a blackout at the university and the timeline remained. So they had to cut by hand, right? And at the very beginning, they had some 10,000 triangles. The moment they realized they have to cut by hand, they say, oh no, I think we're fine with 1,000 something, it's okay. So yeah, this is also a way of rethinking process, right? You have a blackout. Here the prefabrication of the different rings, and then also how do you bring it into the staircase, coming up with a whole hoisting system, bringing it up, putting it into the staircase, and then having the final structure out of paper with a total height of 10 meters. the whole structure was just held together by the staples, right? So the folding lines and the staples. Also, what brings it into shape, we used gravity. So paper, the accumulation of paper, it's quite heavy at some point. It stretches the whole structure and it makes it also fall into place because it is designed as a minimal surface. Happy students, happy tutors. Then for a competition, and this was a collaboration with two of my friends, Carlos Bausa Martinez and Diesem Medina Patatuki, and I misspelled their names horribly on the slides, I just realized. And there we also looked at a minimal structure hanging within a courtyard. Then we won. And then we had to build it. The first thing, well, not the first thing, but at some point when it came to fabrication, the first thing that I did was let's build a model. Whereas we used for the actual building of the structure PET-G, so what your plastic bottles from the supermarket are made out of, and then another foil of golden vinyl. Quite expensive, several thousand euros. On the other hand, these test models cost me £7 because it's just laser cut A0 sheets of thicker paper, again just being clipped together and using the tension force and simply gravity. There is nothing at the bottom, so this is just the standard, right, seen from the side, that is pulling it down. So it's fallen into shape because of gravity at the end of the day. And then we had to make it to Montpellier, and we had to actually assemble it. Here you can see us with our amazing helpers, and this was then the whole structure, right, floating, hanging in that particular courtyard with this type of shadow effect. And that music school kids were extraordinarily happy about that. Now, massive structure fits in a bounding box of roughly 8 by 8 by 8 meters. You have to ship it from Scotland to France. It better be light, else it's becoming very, very expensive. These are all the pieces there, right? It's not a particularly nice image, but it also has to do low tech in terms of how do you transport it, right? How do I make it intelligent? It all weighs 21 kilos. These are the larger PET-G pieces rolled together. There are the other pieces in those two maps. Those are the cables that we use, and here in the nice tiger-colored textile thing, right there we have the golden vinyl, and that was it. 21 kilos, able to transport it in luggage. The question is why, right? So you might ask yourself, okay, this is all very nice, it's very experimental, it's temporary structures. Why? We already know how to build houses efficiently. Where I would say, do we? One of the reasons, and I'm going to answer a question with a question, technology is the answer. This seems to be the slogan and the paradigm we all agree on. But what was exactly the question, right, in terms of that? Well, I'm going to answer it with the quote of Zaha Hadid, where she's saying, architecture is really about well-being. I think that people want to feel good in a space. On the one hand, it's about shelter, but it's also about pleasure. Right, and it's this pleasure that I'm particularly interested in. It's about looking for new material expressions. It's about spatial qualities and increasing the spatial qualities through your intervention. Also increasing the tectonic qualities of architecture, and at the end of the day, architecture ideally should be about humans and just offering people an elevated spatial experience. In terms of elevated spatial experience, and I think this quite often, there is a discourse in terms of sustainability, which is absolutely fair and fine. It's about increasing efficiency, being more sustainable, using less energy, but somewhere on the way, maybe we have also lost the idea of, right, the pleasure of space and the wonder that it can offer. Here we're seeing the Sagrada Familia of Antoni Gaudí, right, that used a unique process of developing this type of geometry, and then also the construction process itself. And stylistically, you may like it or not, but there is a sense for everyone who's stepping into that cathedral, a sense of just being amazed by the space and having a very different spatial experience than before. To then an example from today, right? Even an airport can be maybe spatially exciting. Right, and the second part to the question why, it's also to address challenges in today's construction. We face a global resource scarcity. There is a climate crisis, right? Most of our building practices, they're not really sustainable. The way we source our materials is really, really problematic. If we look at concrete, if we look at steel, if we look at glass, right, and all the components and materials that are going into this fabrication processes, and if we look at the sourcing, very, very problematic. Most of our buildings have a very high embodied energy and very high carbon footprint. You've probably all seen or heard, right, similar statistics, but so we know that the building and construction sector, that they account for 36% of final energy use, 39% of energy and process-related carbon dioxide, of which 11% result from manufacturing building materials and products such as steel, cement, and glass. And worldwide, so we're using right now, I think 2021, 30 billion tons of concrete, and this is 3 times as much as 40 years ago, right? And at least 8% of global emissions for this, that the cement industry is accounting for it, right? Because when you produce concrete, you have, depending, right, a mixing ratio of 10-15% of cement right there. And these are all reasons why I decided to look closer into earth and earth-based material systems. So when we're thinking of earth-based construction, it's maybe at the periphery of our awareness. When we're thinking of architecture, it's a vernacular building technique. It's something that is represented across the globe. So here, for instance, an example from Belgium, but we have it really everywhere in Europe. Here, the Alhambra in Spain, or even very nice dove coats also from Spain, up to then rammed earth construction, experiencing in the last 10-15 years a revival, and this example. What is interesting about earth construction, right, or earth-based construction systems, it's very much still based on manual labor, which some might find problematic, but we're going to get then later into it. Again, clay or earth-based constructions at the periphery of our awareness, but if you're looking across the globe, it's a construction technique all continents, right, have in common. It's represented everywhere. The black dots are the UNESCO World Heritage Sites, right, in terms of that. And we don't really think of it, right, when it comes to building a house of, oh, yeah, that's the way to go. But actually, in today's time, 30% of the world's population live in houses that are constructed of raw earth. And why is raw earth or earth-based construction relevant? Right. First of all, it employs locally sourced raw materials. You don't have to import the stuff from somewhere else. It increases the environmental and economic cost of transportation of construction material, right? It also cuts down the industrial processing of raw materials, right? I can't extract steel from the earth. Not so. There has to be a production chain that leads me to the product of getting steel. We don't really have that when it comes to earth-based construction. You can literally just take the earth and start mixing it and putting it into formwork. Right. It employs thermal mass technology to achieve and maintain thermal comfort. Don't need that overload of sensors in your house and smart devices, and you can achieve a high architectural quality. What is also very compelling, it is really the simplest and easiest construction method, right? You don't need training for that. It can be explained to you within half an hour, and you can start producing rammed earth. It can be used untreated, and theoretically you can reuse it endlessly, meaning that the lifespan of our buildings is constantly reducing and reducing. Why build with concrete, right? Why should it be there forever? Why employ that much steel? You can take it down, theoretically put it back into your garden. And it is a local material, globally available. Again, you can source it from anywhere, and it does not require firing. And also very relevant, it is intrinsically connected to local culture, meaning it is an expression of the culture of the space. The way we build with rammed earth in Spain and Germany and different parts of Africa, South America, Asia, Australia, it is a reflection of local culture and building practices, and this knowledge can be embedded within it. It has a very much reduced environmental impact due to all of the things that I just listed, and it reduces waste. And then labor. And labor is quite important. Also today, or not only today, in the last 15, 20 years, there has been so much conversation about the robotization, about AI, right? Labor just being diminished by it. As architects, we have to be aware of it, and this is a quote from David Benjamin. I work with robots, right? And robots are definitely part of the process, but killing labor is also not the answer. So when architects organize, they not only organize materials, but they also organize forms of labor, meaning a particular material choice implies a particular type of labor. And so there is this double embodiment. And normally we solely focus on the materials and don't really talk so much about the type of labor. But it is very important in terms of sustainability. And this should also remind us that sustainability has to be framed in social as well as environmental terms. Now, industrial robot arm, it weighs 2 tons. There's steel in it. There are rare metals within it, right? There's a whole production line, a lot that comes with it. It has a very high embodied energy. To make a person, to have a person work and execute right, something on site, they only need to have breakfast, lunch, and dinner, right? This is the whole energy input that they require. Very much more environmental friendly than the robot per se, right, if we're looking at embodied energy. And just to give you some examples that are outside of vernacular architecture, here you can see a Swiss bird observation center built out of rammed earth. Rammed earth here, it's not, the walls are not load bearing. You have, right, it's a hybrid system. You have also the frames, the timber frames that are, working structurally. And another example, so earth-based construction within the context of robotics. Here you can see the Tekla house by Mario Cucinello and WASP. WASP is the company that produces this type of small-scale and large-scale clay and earth 3D printers being printed on site with, right, locally sourced materials. And here you can see a top view of it. Now, in the context of this, I'm going to show you now some of our projects that are done here at TU Eindhoven, based on an innovation grant that I got. It was possible to set up 3D clay printing lab. You can see one of our students, Federico, very happy next to the clay printer. The big guy, that is our clay printer, connected to an external mixer and extrusion system right next to it. We not only print with regular clay, we also experiment with pigments. And here, for instance, we use pigments from the company Lanxess from Germany, adding it to the mix. What is also very nice, we never fire our pieces. Once the students are done with their projects, the things have been exhibited, you can just crush the clay, put it into a container, and add water on top of it, and you're good to go in a couple of days' time to start printing again, other than printing with PLA, printing with concrete, where it just ends up at some point in a landfill, right, sooner or later. So it's also a sustainable way of working for the students. We're using algorithm-aided design to explore different types of material expressions. So here you can see this type of patterning on that particular type of prototype, right? And here you can see also some of our prototypes, happy students again, happy tutor, that were exhibited last year at the Robots That Build exhibition and at Dutch Design Week, right? So the term normally when you where to think of clay vases, clay facades, tiles, you wouldn't think of this type of geometry. So there, we're really trying to push it further and further and to get at the limits of the machine and at the limits of the material. If you're seeing here, for instance, right, how narrow right, and twisted that one arm is, and it can still self-support itself. It was printed without any type of substructure. And there also craftsmanship and digital craftsmanship. Why? Clay is an alive material, so there's a lot of parameters how you can influence it. Depending on the geometry that you're printing, you might want to have a wetter clay mix, right, or a dry clay mix. You might want to adapt the extrusion rate and the flow of the machine to be able to achieve that. So you need to have this type of sticky knowledge, intrinsic knowledge of the material, that you can't encode it, right? It's a matter of trying, right? You're just having between your fingers the clay and like, it's too wet, it's too dry. I don't think it will be able to do this. Right. From design objects and design pieces to then, for instance, the seminar that I held last semester with Mattia Zucco from RAP Technologies, we were looking at facade systems. Here's one of our students trying to define clay-based facade system where the water, right, once it's raining, is led across the facade, also based on algorithm-aided design. To another student here, Tom, he was also looking, part of the same seminar, looking at facade systems, trying to explore ways in which, for instance, you could have a green facade and the way that water can run down the different elements and then support the plants. Here you can see, right, some close-ups and yeah. Right. Now, in terms of the design thinking and the digital crafting, once you propose this type of facades, it then becomes a matter of, okay, how do I subdivide? How do the joints look like? So this are renders, and then those are printed pieces. And yeah, if you're not careful with your material, make sure and you don't have that experiential values, it will collapse. Like for instance, there or here. So the printing went well, it went well, printed up till the top right. So this is a render. And then all of a sudden, because the mixture was too wet and because of self-weight, it collapsed, right? So this is also an experiential value. That's part of the learning process. Now, I talked about computational design and robotic fabrication. And this new context of tools, and I spoke about the paradigm shift in the conditions of production regarding robotic systems, but there is another paradigm shift happening right now, or at least in my opinion, which is related to the use of AI, and they're not so much in terms of the production, right, but in terms of design. So if we're thinking of artificial intelligence in architecture, engineering, and construction, so there on the right-hand side, it's about analysis, how to optimize stuff, evaluation, real-time tracking, the building technology itself, automation, efficiency, etc., etc. At this very moment, I'm not interested in the right-hand column. I'm more interested in here, the left side, architecture in terms of creativity, AI as a design tool, AI as something to advance geometric complexity, which then offers a different type of spatial experience. And there, of course, then there's a debate of authorship, who's in control, creativity, and is there still a creative genius? You might have heard in the last year or so, will have been flooded if you're part of the design community or you follow designers or on Instagram, by a lot of images created by Midjourney. So what is Midjourney? It's an AI software. It's text to image, where you are basically, that came too early, typing prompts in, so text, which I'm going to jump back to that one, where you're basically typing in prompts, so meaning words, and it will spit out an image. Here is the screenshot I took at the end of last year. It runs on this platform called Discord, so people are just typing in words and then an image pops up. They scrape the internet. It's supposed that they have a database of 5 billion images, right? It's absolutely enormous, and there, for instance, Queen Elizabeth II just died, so people were typing in stuff, so it's also an interesting reflection of culture, right? So this is the prompt. The software imagines something, I wrote up those words, and then, right, it starts to try to approximate, and at the end, I mean, there is really no end of the process, because you can go endlessly with it, right? At some point, right, I had these different sets of images. Now, the AI can hallucinate architecture, the AI can imagine architecture. Where do we go from here? How do you transform this now into an architectural proposal? How do you translate? How do you rationalize? If we're jumping a tiny bit back and thinking of the trying to map a design process, there's the artist, the designer, the architect, the person. There's something that triggers his or her inspiration. You start to sketch, you make models, you represent it graphically, and it goes back and forth, back and forth. And the idea is that you start at the imagined, the fuzzy, the diffuse, the ambiguous, and you're trying to get to something that is concrete, clear, controlled, unambiguous here in the real world. Just to give an example, so for instance here, the Frank Gehry, the Guggenheim Museum in Bilbao, the famous sketch, models, software, whatever, the building in reality. Now, in terms of Midjourney, how does that happen, right? How are you in control? And there the notion of control becomes very, very important. We're also going to talk in the next points about neural networks and style guns, right? But just see them as the same thing right now, as AI, which then generates synthetic images based on prompts, based on a data collection, based on data curation. So there already the design intent comes in. What type of words do I select? What type of database do I set up? I must have some sort of idea, at least conceptually, what I am after. And this synthetic image creates the baseline or the sketch. And then there is a whole translation process happening where, as an architect, designer, etc., the creative thinking has to kick in, because you do have a simple 2D image at the end of the day, which comes as an output from neural networks or diffusion models. And then you have to go from 2D to 3D. You have to show some material understanding, the images that I showed you before that Midjourney spit out. Can I actually build this out of clay or rammed earth? How do I have to modify it that I can transform it actually in an architectural design proposal? So the idea is here that also you're starting from the imagined, the very fuzzy, literally and metaphorically, because the images are fuzzy, right, to then getting something that is unambiguous and then a higher amount of control. This is from one of my master studios run last year at TU Eindhoven together with Fraser Morrison and Dong-Yun Kim, who's a specialist in machine learning. And there, for instance, we used and we encourage our students to use Midjourney as a device to try to find new material expressions, new spatial and tectonic expressions related to mud and earthen construction and earth-based systems. And there, again, right, you can see that the variation of the different images, again, theoretically the process is never ending. You have to put a stop to it and then say, okay, what am I after as an architect? What is it that really interests me? Where do I hit stop and start then to translate into a real proposal? The way we also use Midjourney is to do, for instance, studies of really material expressions. So here looking at aggregations of brick and clay and mortar, trying to see how can you play with it that you get this type of very unconventional, right, stylistic expressions. To then even when it comes to circularity, for instance, thinking, well, there's so much construction waste. What would happen if I'm just taking the bricks, the mortar, the concrete, rough as it is, and trying to do to examine what type of columns or structural elements I could do out, I could make out of it. And then we're using now neural networks and style guns. So if we're looking at the field of AI, there we have a subfield that is machine learning. Within machine learning, we have deep learning, and somewhere right addressing machine learning and deep learning, we have neural networks. Just a very quick, I'm not going to go into all of the technicalities of how deep learning works and how neural networks work, but just as a proximate definition, right? So the machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience, right? So the learning part is coming in here. And what are now neural networks, right? So they are function approximation algorithms, right? It's not about getting a sharp image. It's about having an approximation, how it's set up also with the generator and the discriminator within the algorithm, having a synthetic image that approximates something. What that something is that comes in through the database. And what a style gun is a generative adversarial network. They were only developed 2014, 2015 by the scientist Ian Goodfellow. And what they do, again, a very simplified definition, right? So style gun, it renders features that were recognized by the neural network in the database, 100 images, 500, 5,000, a million, 5 billion, right? Recognized by the neural network, and recombines the pixels into a new image outside the conventions through which we as humans understand the depicted object. Meaning it doesn't know that you're feeding it 3,000 images of faces, right? It looks at the pixels, right? It doesn't understand, there's no understanding of, right? There's no awareness of it. To make it clear, right, so here's a latent walk that was generated by one of my students, Xavier, as part of the Master Studio Material Ecologies, where he had two databases where we were looking at the port of Rotterdam, at industrial infrastructures that are there, that are obsolete. So you can see here silos and cranes, and how these can be rethought in terms of their components to form new aggregations, new types of assemblies. And this is not this effect of estrangement. So you can recognize some familiar parts as a whole, right? It doesn't look familiar anymore. Here another latent walk, right? See again the morphing, right, and how the pixels are being reconfigured. Here another one, this is from Harm, another one of our students, where Harm, for instance, he was very much interested in the generic modern type of interior and what is happening when you morph it with greenhouses. Why greenhouses? Because we have a lot of them in the Netherlands, and if we tear them apart, right, it's modular. It's a modular system, so it can be reconfigured into different variations. Up to using also style guns to try to explore new type of textures, new types of material expressions, whatever that may mean. And here you can see again another type of really interesting morphing, where it is really up to the viewer to see what is this, could this be steel, is this something that is bio-based, how do I translate it now into reality and make a material choice. Just to give you a graphic, right, of our, via this graphic, an understanding of how we set up our neural network. So for you have two data sets, you're doing the pre-training of the style gun. Here it was a very initial phase, just 500 images. Normally the students work with 3,000 to 5,000 images that they scrape off the internet. And Gregory, he was very much interested in earth and mud architecture, which not typically, it has openings, but you don't really have balconies. It's also a matter now of the climatic context, where they're from, etc., etc. So it was really interesting, okay, what is happening if I combine these two types of data sets? The ticks that you see here, this just stands for iterations. And then you have, it comes through a latent walk, and you have at some point to select some seeds, meaning images that you feel are relevant based on your own standards, ambitions, whatever you at the end of the day as a designer read into it. And then he selected these refined images for the design. And here generating 100 seeds, selecting the ones which he felt are relevant for his design intentions, and then trying to rationalize them and to see, okay, right, if this is an exterior facade, how can I bring it into architecture? How can I actually build with mud this way? Would this be how a section looks like, and how can I rationalize it? So looking at these images, trying to get closer and closer, and then using in parallel also a database that was made out of mid-journey generated images to try to explore in more detail how the interiors of his architecture could look like. A lot of iterations in between, making another data set based on mid-journey, marrying it with another data set where he was like, okay, I really want to understand what is happening on the facade level, right? So how can I refine the facade to then, right? The reason why I'm showing all of these iterations is because quite often it's like, oh, it's AI based. Whatever, what did you really do? Well, there are a lot of levels of control and design decisions that have to be made in order to achieve what you would like to achieve. And there is, of course, a degree of black boxing and randomness via the AI, but there is definitely a way to stir the process in a particular direction. To then selecting these two synthetic images, trying to accommodate the different functions within floor plans, but then this is not enough, no? How would you actually build it? So then using computational design, right, and different types of techniques of trying to understand what would it mean if a tower were built this way, how many floors, how does the core work, how would the facade look like, right? Why is this too dense? It would have too much weight, it would self-collapse. So going through very, very many iterations to then also not ramped earth is very good for compression. But you need other material systems also to make it structurally stable, particularly when you're going vertical. So trying also to rationalize this and have proposals of how this could be done. Here's some sections of it, to then trying to also 3D print, right, the thing, where this is where you can see here, so very dense openings, what is happening in theory, but then also in reality it will just collapse under its own weight. So lesson learned, you start again, right, a bit bigger openings, understanding that, okay, for reducing the shell, I would maybe just need a double shell, to then, okay, this is not what my design intent was like, I need more light inside of the building. This is possibly what reflects best my design intent. And then also understanding, right, how do I work around this way, because gravity is kicking in, right? So there you can see the layers starting to sag. So how can I work with the material mix, the speed and viscosity, that I can keep this at a minimum and still have my geometry. And now a last example, here another student being interested in vernacular earthen architecture. right? And this were, I'm not going to go again through the whole process, but this were then some synthetic images that came as a result out of it. So you might recognize familiar parts or parts of the image, yet the whole, right, looks very strange. Going through different processes, and then at the end of working with the neural network, he felt that these two synthetic images are the ones that have the most spatial qualities. Was a museum also for the Port of Rotterdam, and now how would I build this? Looking at timber frame structures with rammed earth bricks, starting to rationalize the whole thing, right? Turning it into a constructive system, to then having this type of dome-based floor plan, where he felt the need also because of weathering conditions in the Netherlands, also protected with a dome on top of the other domes. Here you can see also considerations in terms of the construction process and assembly processes on site, how cranes and robots are used as part of it, right? To then his final design proposal of the rammed earth-based museum within a dome for the Port of Rotterdam, and this type of interiors, and this being his final design proposal. Now, what I would like to conclude with is that we do have all of these devices and softwares, right? Computational design, robots, AI now coming into the game. But at the end, there's a lot of debate, as I said before, about creativity and control, and will architects, designers, whatever, be left jobless if the machine can be more creative or hallucinate better than us humans. And I think, well, it's an open question, but we shouldn't underestimate the human contribution part of the process. And here, the pencil and computer are, if left to their own devices, equally dumb and only as good as the person who's driving them. Thank you. Yes.
First, thanks for the very nice presentation.
You're welcome.
I have 3 questions. So, I find it very interesting that you take the approach from the aesthetic side. So, from a sculptural or pressure side, like Dieter said. Did you ever consider to train the algorithms you use also technical design rules? You could maybe even do that with pictures, saying that's a stable or printable shape.
Right. Yes, so it is being done. Myself, I didn't really look into that because I'm more excited about what we can do with our spaces, because at the end of the day, to really technically optimize something, you have to set very precise parameters of analysis, very precise parameters of how you evaluate them and how you then optimize what it is that you're looking at or looking for, right? That needs optimization. And that, for me, at this very point, was not of interest, which is not to say that it might not be in the future.
So I would challenge the precise, but the 2 other questions, very short maybe. How do you define technology, and how do you define digital?
Right. I mean, technology, it's, we need another philosophical question on that. It really depends what we're talking about. So right now, for me, technology within the area of architecture is everything that includes the manual, the hand, really, like starting from the digits up to software, hardware, and tools. And for me, it's a matter of how do you hybridize these things, because it's not a choice, either one or the other, but they all bring positives and negatives, or they're more suitable for something particular. And it's about how do you find those strengths depending what it is that you're after, what it is that you need, and how those can be combined. And I think it's very complex equations that one has to look at, because we live in a very complex and entangled world where, for instance, a choice for a robot, it might sound, it is extraordinarily efficient, but again, the robot has a huge material footprint. scattered across continents, just because of the material sourcing that it has, right? So the fact that it is green and clean when you look at it abstract in a factory, right, and this is the point zero of where someone is looking at it, right, doesn't mean that actually, right, the equation overall, right, and the complexity of the world, of the planet, that it is that beneficial. It depends, again, what are you doing with it.
And your definition of digital?
Well, the digits, right? I don't know, and what, it depends on the context, but in terms of what I'm doing, it would be everything that is driven by software, let's put it this way, controlled by software.
Yeah, in terms of using like earth materials like clay in building and construction, I can imagine that would work for certain parts of the world. But for instance, in the Netherlands, where it's always raining, like you said, the prototypes of the students, you also crush them, throw them, add water, and it becomes clay again. Did you do some research into this, how this might be solved?
Yeah, so for instance, the build examples that I showed, they were from Switzerland, right? I don't think there is a difference between the Swiss climate and the Dutch climate, but it is not that substantially different, right? So also you build with rammed earth in areas of the world where you have monsoon season, right? So a lot of rainfall. And the idea is also that when you're building with rammed earth, for instance, they are structures that also require intervention, right, at some point. So you do need to reapply a layer of plaster at some point, but which is fine, right? It's just plaster, right? It's very simple manual labor. So the thing that it's not suitable, yeah, maybe don't build in the Arctic with it, maybe don't, right? But that there is an issue around the weather conditions within Europe that is overestimated.
Yeah, I have a question, I think, for a question as well, because in regular earthworks you have these erosion checks to like stop the waterfall,
yes,
right, and like stop the water from penetrating through the material. But how would that, because you're having this design approach, how would these erosion checks and other construction methods or like complications go into the end result? Like say, if we were to upscale these shapes and then think of, okay, if that's a building, you need to add erosion checks, that will alter the complete expression of the building.
Yeah, well, it is a rationalization process. So the point is not to have the identical building, right? The identical synthetic image. So the synthetic image is a very early step of inspiration, right? That you then have to translate. So as you saw here in the project of Jimin, right? So this is the final outcome. This is the image, right? So the ambition is not to build this, right? The ambition is to say, well, this is something that I find spatially interesting, or it gives me something spatially, and how do I rationalize that and translate it? And the rationalization, right, you can move very far away from it, like Jimin did, right? Or you can stay very close to it, like in the case of Gregory. Right, so it's not about building exactly that, right? So it's one of the steps that are part of the creative process and that you are guiding, but it's very early, no? It's the same way when you work in an architecture practice, right? 10% is the design phase, 90% is building it. Nothing changes from that perspective still.
But adding that as well, like if we still think of these erosion checks, how do we, like if we were to clay print the building, would we have to push these checks in manually in the end? Like I think of this robot going around and like making turns, extracting the shape. How would we put in like external materials that need to be added in the end?
You can spray with earth also, right? So basically your concern is how do I keep the same complex geometry when I have to apply stuff on it?
Sort of.
Yes, right, where those layers are very thin, no? Right, so you can apply them with drones, so it's because you're not applying something like this on top of it, right? So we're talking very, very thin layers that can be sprayed. You can spray them with drones at the end of the day. You can do earth shot with it with robots. So that is a maintenance issue, but it's not a big issue, so there's nothing from a technical perspective, standing in a way of addressing that.
I'm aware that clay has the material property of being heat treated.
Mm-hmm.
Have you put any of the models in ovens or tried to test them how they react when they're...
Well, it's regular clay, so the moment you fire them, we have fired a couple of them, right? In particular in Edinburgh, I was firing quite a bit. There's a shrinkage that is happening, right? Depending on how long you had it standing, or what the mixing ratio was in relationship to water. But it's as if you were to fire a vase.
And does it make it more strong?
Yeah, of course, yeah.
So
Yeah. But rammed earth, you don't fire rammed earth. Right? But it's also firing is very energy intense, right? So at the university, there is no point in firing, right? So you can move the models around, students can showcase them, and once you're done with it, it just ends up in a bucket and you spray water on it. The cycle of life, right? So there is absolutely no need to compromise the material, fire it, and then what, right? You'll have it best at home for a couple of years. Worst case scenario, like it will end up in the trash after, or mom and dad will just like needs to go, right? Yeah.
I have another question. So it just occurred to me since you put an emphasis on the spatial experience, and you also have a citation there, this whole debate, is architecture just shelter or sculpture? So you do not consider the temporal aspect. So could we maybe say that the user interaction with the building is temporal, and given that you put an emphasis on the spatial aspect, you inherently imply that it's more sculpture than architecture?
Well, it depends really across the scale. So, for instance, I'm not sure if I'm understand the question, if I'm answering it accordingly. So you have to tell me. But for instance, if you look at the early examples that were made out of paper and out of PETG, that is definitely temporal, right? So there, the idea is it was really time restricted till I don't know, the Festival of Architecture lasts, or when we get sick of looking at it, right? It's just coming down, but while it's standing up there, it modifies the spatial experience, right, of going through.
The life cycle of the building, but the interaction is always temporal, right? So it's also linear. Yeah?
Yes.
I walk into a building, so it's kind of storytelling. I open the door, I'm in the first room, I go to the next room. So my user interaction is maybe better described in a temporal context than only in a spatial context.
Yeah. We're not doing that yet.
Yeah.
But it would be interesting to do that, yeah.
I have a question about the paper sculpture in the staircase in Edinburgh. You said you made use of the gravity.
Yes.
But to what extent did you take that into account in the design, because you get a slightly different result than the soccer plan?
Right. So we take this into account already when we computationally model it, because it is based on a minimal surface. So the minimal, oh my God. Right. So the minimal surface per se, you guys suffered a lot. Right, through a lot of slides. Where are you? Yes, definitely. Let's see. Right. So also this structure here, but also the other one. So they're designed as minimal surfaces. So basically, what minimal surfaces are, you can also look at soap bubbles, right? So they form a minimal surface. Otto was working with them. So already when we model them within a plugin in Grasshopper that is called Kangaroo, their gravity is a consideration of it, right? So it takes that particular shape because of gravity also acting upon it. So already when you start, right, with this, right, this is why this render, or the render of that we had of the staircase, right, this is why this, right, overlaps almost identically visually with what this thing is, because it is there already. And again, right, so it has only 4 points of contact, and it's really hanging in there because of the simulation and how it was designed. So it's not something that you have to reverse engineer. Right? Yeah.
One final question.
Yeah, when you talked about these projects, you referred to the shapes for the tessellation to be self-similar.
Yes.
That was just a coincidence that you chose self-similar shapes?
No, so self-similar because basically the power of computational design is that I can write an algorithm that subdivides all of these things according to some rules. Now, they're self-similar, yet not identical, so this means not all of them are a polygon. All of them have the same type of pattern, which again changes, the openings become wider and bigger, so their characteristics that define them are the same. They're polygons, they have openings that are triangle based, so they're all self-similar, they form a family, yet they're not identical because they do have varying sizes. So if I put this guy on top of this guy, right, this is 4 or 5 times bigger. Yeah.
Thank you so much for this wonderful presentation, and thank you for answering all our questions. Thank you. I would suggest everyone hangs around and carries on asking some more questions if they feel the need to. Feel free to mingle around. I will come and ask you in a few minutes as well if you're interested in staying for the meetup table, which is a shared dinner that we offer our visitors of the Innovation Café for €19.50. We are here every week for the Innovation Café. Next week we have Jari Fuller here talking about his invention on how to have stickers that change colors and that can be used in mass production. And do check out the website ehvinnovationcafe.org for our further program for the upcoming Thursdays. But for now, enjoy the evening and see you next time. Thanks.
Hey, you're still here. So you like the video. If you want, subscribe and click the bell.